Historyworks has made this short online explanatory video called APP101 because we hope it will serve as a useful introduction for those we work with at museums, galleries, heritage sites and cultural organisations. The film explains some of the choices that must be made when contemplating app production, and then reviews some popular apps that have been produced by museums and cities in the UK. The word app is short for application. In computing, that's a self-contained program or piece of software designed to fulfill a particular purpose. An application runs on the operating system onto which it's installed. It's especially as downloaded by a user to a mobile device. At the time of making this video, there are three main platforms for mobile app development. There are two native OSs, operating systems, written solely for the devices they operate on. That's Apple's iOS, running on iPhones and iPads, and Google's Android, running on devices such as the Galaxy S3. And then in third place, and worth keeping an eye on, is Windows 8 RT Phone 8, a cross-device operating system. Symbian and BlackBerry are losing ground at the rear. Now, these native operating systems compete with the language of the web itself, the increasingly versatile HTML5. These charts indicate the popularity of various different operating systems and devices. Many publicised apps run on the Apple iOS. A reason for this is demonstrated on the next two slides. Device resolution is key. Now, that's how big the screen is and how much data can be displayed based on the number of pixels or dots on the surface. This shows the number of screen sizes or resolutions for the Mac iOS, that is, Apple devices. Add to that the iPad mini, which isn't on here. This picture shows all the possible sizes and resolutions of various other devices. This is the potential number of sizes for Android, with many resolutions and many devices. As a result, apps written for Apple's iOS devices can have their design refined for a smaller number of screens, but still reach a large audience, while on the other hand, Android apps must either be designed with the ability to scale, hence making it harder to achieve the standard design and elegance of many iOS apps, or be limited only for running on a handful of devices, narrowing the audience. The next thing to look at is which is best, writing your app for and stored on the device, as opposed to writing it for the web so it's freely able to use over the internet. Native apps have the advantage of being able to use the system UI, the user interface, which should be familiar to the user and does not need to be created by the developer. Since the system used for native apps, that's the Google Android, the Apple iOS, the Windows 8, is optimized for touch use, native apps generally offer a smoother experience, while web apps, being slightly choppy, may respond unexpectedly to some touch gestures. Native apps have greater control over in-system commands, such as controlling rotation or downloading content from other apps. On both the native platforms, that's the Google iOS and the Android, there are built-in purchase models, which enables the user to buy additional content directly via web stores. Web apps must be downloaded for each use. Very little data can be cached, that is, stored or held on the device, so a strong, fast internet connection is needed. That's not the case, necessarily, for native apps held on the device. As long as they've been adapted to suit a broad range of browsers, web apps are cross-platform, Mac, PC, Android, iOS, Windows 8, whatever. That is, they can be used by almost any device capable of web browsing. On the other hand, native apps must be coded, that is, specific software rewritten for each platform and sometimes also each device. Native apps can only be made available through official channels, that's Apple's App Store or Google Play, and that requires a strict set of guidelines to be adhered to. Web apps are more easily updatable. since a new version can be put out on each user request and can be produced and made available independently of Apple or Google control. Initially, web apps are more accessible, in the sense that they only require the user to type in a web address, as opposed to searching and downloading an app from a store. Native apps are generally, though, more expensive to develop because more specialist skills are required to write the software, and they have to pass stringent tests laid down by Apple and Google, and companies that do this kind of work are fewer in number and can therefore charge more money. How important is offline use? The use of the app and its data when the user has poor internet access, or indeed none at all. If you download the material built into the application, the app, before you go out into the field, then you can access the data at any time. If not, you are reliant on data connection to the internet via Wi-Fi or via the phone's own data connection. That could be 4G, very new, 3G, data over phone, or it could be nothing. Web apps require that all the data is downloaded each time the user uses the app. This is not only expensive if mobile data is being used, but means that the app cannot be used offline, on the plane or underground. Significantly longer loading times that happen when you haven't got a fast internet connection also impact on the performance and the user experience. So this means that web apps can work fine when fast internet access is guaranteed, but are literally non-existent when connection is patchy or unavailable. Now, there are restrictions on the development and sale of apps through official channels. For the Apple App Store, iOS, files under 50 megabytes must really be downloaded over Wi-Fi. Those below 50 megabytes can potentially use cellular data. This is important to consider if the user may choose to download the app on the go, and it might be a very large download. There are many stringent guidelines apps must adhere to, and each app is individually reviewed, so it can take some time to be made available. As of writing, Google Play apps can be downloaded over any wireless network, regardless of size. However, the downside is that these apps must be downloaded wirelessly and cannot be downloaded onto a computer first and then transferred to the device. However, apps downloaded from sources other than Google Play can be downloaded non-wirelessly. A few things to say about GPS, Global Positioning System. It tells the device where it is. GPS relies on a combination of factors to determine where you are. At its most basic, it tells you where you are based on the phone mast you're getting your data from. So in this picture, the phone mast is at the center of the circle, and the GPS software in the device is getting no other clues. Those clues could be a wireless hub you might be trying to connect to, or a spot determined by satellite triangulation. But what this shows is if you're just using the data that's coming from the phone mast, you could be in quite a wide range of positions. GPS is good for general location, but sometimes it's not very accurate. There's very little coverage indoors, and if left on, it's a large drain on the battery life of the device you're using. Let's have a look at some examples of apps that have been out there for the museum heritage sector. Let's begin with Street Stories. Street Stories is made by The Guardian and is native for the Apple iOS device. It's got a simple user interface and it means it's easily accessible. Stories are concentrated over a small area. There are two modes: Auto, which gives you a large view over a large area, and Manual, which hones you in on small individual stories. Street Museum is made by the Museum of London and again is native for the iOS. Street Museum looks great on the surface, but when you get down to it, the actual locations are quite far apart and there's not very much information. It's good for the experienced user, but not so good for the inexperienced. If this were on a small device, you might not be able to make out the text. At this point, we're going to introduce the QR code. What a QR code does is basically interpret the black and white patterns to take you to a specific web location. Here's a few examples just to let people know that QR codes can be made quite interesting. What happens here is if you take a picture of this symbol, encoded within the pattern is the location of the website concerned. So, for instance, the top left-hand one will take you to the BBC, bottom right to Cork Bin. But this does mean you have to have an app on the device you're using which will interpret the pattern of the QR code to take you to that website. Oxford Explore is made by Oxford City Council. It is only a web app. It uses a square user interface, and this scales well between screens, but doesn't look particularly slick. Here's a map showing locations where there are signs with QR codes and numbers. This needs the placing of steely or posters with codes that people scan with their devices that links them to the website and the individual page connected to that location. We think this is quite a young person's kind of thing. Sometimes a simple short URL is both faster and easier to remember or share. Next up is Know Your Place, a sophisticated collaboration between Bristol City Council and a number of local museums. The map contains a different range of accessible data, here highlighted with different coloured diamonds. You can download audio about a place in terms of oral history, or zoom in using a spyglass. And there's the possibility of collaboration from members of the public in the form of uploading comments and thoughts. What you have to decide is what you want your app to deliver. To see a range of the apps that we've worked on, go to the Historyworks webpage at historyworks.tv, tweet us at historyworkstv, or email historyworkstv@gmail.com.